In this example, we are given a square coil of edge L which is carrying a current I2 is placed near to a long straight wire which is carrying a current I1 as shown in the figure. Here we are required to find the work required to rotate the coil A, B, C, D about the axis. This is the given axis about the edge BC by an angle 180 degrees. So we are going to flip this coil from this position to the dotted position, and in this situation this new position is A dash D dash for the edge AD after rotation by 180 degree. So here we are required to find the work done, and here in solution we can write the work done in the process. We already studied in basic theory videos that the work done in rotation of a coil can be given by current in coil multiplied by the change in flux phi1 minus phi2, if phi1 is the initial flux and phi2 is the final flux through the coil. So we are going to calculate the flux through the coil in initial and final stage, and then we substitute over here. So here we can write initial flux through coil is, here we can calculate phi1. Here the flux through this coil can be calculated by considering an element because the magnetic field due to I1 will be varying in this coil. So at a distance x from the wire, we consider an element of width dx. If this element is of width dx, then the magnetic field at the location of this element can be given as B is mu naught I1 by 2 pi x. So here phi1, which is the total flux through the coil, can be written as integration of B dot ds, where we can see the magnetic field due to this current is in inward direction, and the area vector of this coil is also in inward direction, so flux will be positive, and here dot product will be giving us the same value. So here it is integration of, we just omit the dot product because the angle between B vector and area vector is 0 degree. So here it is integration of BDS, which is the integration of B we write as mu naught I1 by 2 pi x multiplied by the area of this element we write as LDX, and we integrated within limits from R to R plus L. So on integrating, this is giving us mu naught I1 L upon 2 pi, and 1 by x dx will be integrated to ln x, and limits we substitute from R to R plus L. And here the result we are getting is mu naught I1 L by 2 pi. Substituting the limits from R to R plus L, this is giving us ln of R plus L by R. This is the value of magnetic flux through the coil in its initial stage. Similarly, if we calculate the final flux through coil, then this can be given as phi2, which is again integration of B dot ds. But when you consider an element over here in this final state, we consider again an elemental strip, again at a distance x from the wire. Here you can see when the coil will flip, the current would be flowing in this stage in anti-clockwise sense as seen from above. So magnetic field is still in downward direction or inward direction due to I1, but its area vector is in upward direction. So here B dot ds will be negative integration of BDS, which is minus integration of mu naught I1 by 2 pi x LDX. Integration limits will be from this point to this point, so x value from here to here will be R plus L to R plus 2L. This will be from R plus L to R plus 2L. If we integrate this mu naught I1 L upon 2 pi, 1 by x dx will be ln x, and limits we substitute from R plus L to R plus 2L. and if we substitute the limits, and here there is a negative sign also which I missed. So here this will be minus of mu naught I1 L by 2 pi ln of R plus 2L by R plus L. That's the final flux, which is negative. So if we calculate the work done in rotating the coil by 180 degree, is this work done can be given as I2 multiplied by phi1 minus phi2. So here if we substitute the values, phi1 is this, which is I can take this mu naught I1 L upon 2 pi, I can take this term common out, and inside I am having ln of R plus L by R and minus of phi2, so this minus and minus will become plus. This will be ln of R plus 2L by R plus L. This is what we are getting, and further on simplifying this value, we are getting the result mu naught I1 I2 L upon 2 pi, and this will be ln A plus ln B will be ln AB. So here the value we are getting is ln of R plus 2L by R. That's the result we are getting for this problem. That's the total work done in flipping the coil from initial state to final state.